In this video, we are going to discuss number 12, starting with number 12 part A. Here we are given a list of probability values. P of A is 0.33, P of B is 0.44, P of C is 0.22, P of A intersect C, or A and C, is 0.06. And also, we have been given an added piece of information where A and B are independent. And we are given a list of formulas for independent values, independent events. A and B is calculated by multiplying the probability values, P of A times P of B. P of A union B is the addition rule, P of A plus P of B minus P of A intersect B. And the rule for conditional events, P of A given B, or A if B, because this symbol you can say if, or you can say given, is P of A intersect C over P of B. So part A, we need to calculate what is P of A intersect B, or P of A and B. Because for this symbol, you can say the word and. You can say intersect, you can say and. So as you can clearly see, A and B are independent, so you can simply multiply their probability values. That would be 0.33 times 0.44. P of A times P of B to give us a value of 0.152. Part B, P of A union B, you can say union or you can say or, P of A or B. Here is the formula. So you simply apply the addition rule formula is P of A, which is 0.33, plus P of B, which is 0.44, minus the intersection, which we just calculated in part A, which is 0.1452 to give us a value of 0.6248. And part C, P of A given B. For this symbol, you can say given, you can say if, you can say after. P of A if C, or P of A after C, is the intersection of P of A and C. Here it is, 0.06, divided by P of C, because C is the condition, which is 0.22, to give us a value of 0.273. Now we move on to part B. It says, consider the following contingency table analyzing the relationship between academic major and mathematics score. So here we've got a contingency table, which is a two-way table, and you've got the row variables and the column variables. You have major as natural sciences and social sciences, and score will be less than or equal to 40, between 40 and 70, and more than 70. And here you have the row totals and the column totals, 175, 155, and 40, 160, and 130 respectively, and the grand total, which is 330. And here you have the intersections. So for example, natural sciences and below, lower than 40, you have 15. Natural sciences and between, you have 70, etc. Social sciences and more than 70, you have 40. So these values, 15, 70, 90, 25, 90, and 40 are the intersections. So having analyzed the mean of each of these numbers, we can solve part A, which says find the probability that n. What is the probability of n? Okay, one student is selected at random. So what is the probability that this student is from the natural sciences? So we need to find how many students out of the 340 are from the natural sciences. And as you can see, there are 175 students from the natural sciences. Here it is. So the probability that this student is from the natural sciences is 175 divided by 340. And here it is. Part B says, what is the probability that this student is from the natural sciences and got a mark lower than 40%? So we need to find the number of students from the natural sciences and it is scored lower than 40. That's 15 of them out of the 340. So therefore, the probability of such a student is 15 divided by 340. What about the probability of finding a student who scored more than 70% or is from the social sciences? So this here we have to use the addition rule for probabilities. So we need to find P of M plus P of S minus P of M intersect S over the grand total. And here P of M, that's 130 out of the 340. S is 155 out of the 340, and the intersection is 40 out of the 340. So this is why we have 130 plus 155 subtract 40 out of the 340. And D, what is the probability that this student scored between 40 and 70, given that they are from the natural sciences? So after knowing that they are from the natural sciences, what is the probability that this student scored between? So we must use the conditional rule for probabilities, which is the probability of B intersect N over N. N is the condition. Now B intersect N is 70. So the probability of B intersect N is 70 over 340. Here it is, divided by the probability of N. The probability of N is 175 over 340. So we've got a fraction over a fraction. The 340 is cancelled out. So this is supposed to be 70 divided by 175 because the 340 cancelled out. So please take out your pen, your paper, your pencil, and your calculator and to actually do this question so that you can make sure that you are able to do it in the eventuality that it comes up in your evaluation. Oh, the fractions can be left so. If you want, you can simplify them or you can convert them to a decimal. But keeping them like that is acceptable.